Hello. Today we're going to carry on working on our character sheet and focusing primarily on item management. As you can see, I finished the character sheet from the last video, but it's got a few issues. I can add items by dragging them from the items tab or a compendium, but it can be tedious to do that for simple items like skills in our system. So instead, we can give ourselves the ability to create items directly on the character sheet. To that end, we need to start by adding some kind of button to the sheet to add a skill. I'll be placing mine at the top of the skill section next to the title. If you want to add icons to your sheets, there is a shortcut. Foundry uses the I element to denote icons and special CSS classes to pick which icon to display. So to create an icon, we want to add an empty I element and give it two CSS classes. The first one is always going to be FAS, and the second one is going to be FA-something, where something is the name of the icon you want. These icons are picked from the Font Awesome library, so head over there to see what is available. I'm not entirely sure which set is bundled with Foundry, but I'll wager that anything in the free set is available and should cover most of your needs. Since I'm creating a button for adding skills, I'm going to go with A+. Then, to turn this into a hyperlink, we will wrap this in an A tag to which we'll add an item-create class. For good measure and accessibility, we'll add a title that will be displayed as a tooltip so that the user knows exactly what this button does. Next, we need to hook this up in JavaScript. This happens in the actor sheets code, where we will override a function called activateListeners. This is the function where you can turn the sheet from a simple form into something a bit more interactive. If you're planning on doing some game automation, you'll be spending a lot of time around here. It gives us the HTML code of the sheet as a parameter, which we can use to retrieve elements of the sheet and react to some event. Most lines of codes in this function will follow the following pattern. We search the HTML for a CSS class selector, pick an event we want to react to, and then assign a custom function as a callback. More often than not, you'll be listening to mouse events, keyboard events, and form events, the complete list of which you can find in the jQuery API documentation, which I've linked to in the description. At the end of activateListeners, we should also call the parent function to maintain default functionality such as dropping items onto the sheet. For the callback, we need to do this binding procedure to ensure that the keyword this still refers to the actor sheet instance when inside the callback. For our button, we're going to look for our item-create class and make it so that we call a function called onItemCreate whenever we click on an element with that class. All callbacks take a parameter that gives us some information about what happened, like what HTML element the event comes from, which buttons were pressed, etc. In most callbacks, we'll want to start by calling event.preventDefault to avoid other callbacks being called. We will also want to cache the HTML element the event comes from, which is stored in event.currentTarget, assuming that this information is relevant. In order to create items, we will call the createOnItem function on the actor whose sheet this represents. This needs some info passed to it in the form of an object that I will call itemData. At the very least, this itemData needs to contain a name for the new item. I'll call this new item, but remember, we don't want to hardcode text that we might need to localize, so we will have to call game.i18n.localize and pass it the path to a string in our language pack. The second thing we need to specify is which type of item we want to create. We know it's skill, but let's stop and think for a moment. You might have gotten the hint when I named the CSS class item-create rather than skill-create. It should be pretty obvious that we could be using the same code to create any owned item rather than copy-pasting this several times. But this means we need to pass the type of item we want to create to this callback somehow. This is where HTML data attributes come to the rescue. Any attribute in an HTML element which starts with data dash gets grouped in an object called dataset. So if I were to add to my A tag an attribute called data-type and set that to skill, I could then go back to the item creation callback, grab element.dataset.type and put that into the item data. Let's check this in Foundry. Great. I'm quickly going to do a bit of CSS layout because I want the button and the title to be on the same line, and I want the button to be at the end of the line. The next problem is that at the moment we have no way of editing owned items. As you probably know, owned items are unique to the actor, copies of the items you dragged into the sheet. For skills, you can see I used form input so that I can update the skills directly without having to open an item sheet. But But if I modify a skill, close the actor sheet and reopen it, my changes are gone. This is because we have to make the changes to the items ourselves. To do so, I need to prep the actor skills HTML. To each of the input elements, I'm going to add a CSS class named inline edit, as well as a data attribute that I will call field, corresponding to the property this should modify. In this case, name and data.value respectively. If you didn't notice in the previous videos, I should note that the div that contains those inputs has an item class and a data attribute called item ID that contains, well, the ID of the item. We will need that in a short while. Now we can add a listener for the inline edit class and we'll be listening to the change event, calling back to a function we will name onSkillEdit. There, after doing the usual callback setup, we'll look for the closest HTML parent element containing the item class and extract the item ID from it. This allows us to retrieve the actual item and update it using the information from the input element using the item-update function, which takes an object containing the properties that need changing. Now, the changes to skills should persist. For items that you don't want to edit inline, you still need to be able to edit them somehow, which you can do by simply calling the items sheet. I will demonstrate this with sticks. The procedure is similar to the add skill button, but this time I will be using the heading as a button rather than adding an extra icon, mainly to show you a different method. I'll add a class called itemEdit, then listen to click events on it, sending them to A on itemEdit callback. There, I can retrieve the item the same way I did for the skill edit, but instead of updating the item, we'll call item.sheet.render with the true argument to force it to open. Finally, we want to be able to delete items. The process is similar, so I will fast forward. You create a clickable element, you get the item ID, and this time you call this.actor.deleteOnItem. And job done. Please bear in mind that item deletion is immediate and irreversible, so pay attention to where you place those buttons. You'll note I haven't set up buttons for the additional gear, but it's the same thing, you get the idea. For weapons, I want to do something different. I don't have a lot of space to put icons, and I want the action of clicking on the weapon to do something other than edit the item. So what I can do is put the edit and delete actions in a context menu. Foundry has a context menu class which makes the whole process pretty easy. In activateListeners, we will call the constructor for context menu, which takes 3 arguments: the HTML content, a CSS selector referring to the bit of the page we want to have a context menu on, and an array defining the context menu options. You can define them inline, but I'm going to place that in a variable in case I want to use it somewhere else. The context menu definition is an array of objects, where each object is a menu item. For each menu item, you can define the following: the name of the menu item, an icon, using the same format we've used when we added icons to the sheet, a callback, i.e. the action the menu item is meant to perform. This uses an arrow function expression, where the parameter is the HTML element the context menu is attached to. And finally, we can optionally define a condition which must be met for the menu item to be displayed. This also uses an arrow expression function. And that's it. It's all you need to do to make context menu. Now I should be able to right-click on a weapon and call its item sheet, or delete the weapon altogether. Next, let's look at the marks of death. Here we have a number represented on the sheet by several icons. I don't really want to make space for a text field or hide it, so I'm going to make this clickable instead. But before I get to that, I need to create a CSS class and a rule so that the appearance of the icon changes when it's checked. I'll call this crossed, and for now it's just going to invert colors. I'll do something fancier off camera. I'll temporarily add that class to the icons just to check that it works. Obviously, this is changing the look of all the icons when we only want to have a number of icons equal to the value of the stat to be altered. In the handlebars template, we can do this by surrounding the crossed class with an if statement that tests the value of the property. There are a few things going on here, so let me explain. GTE is a Foundry-specific handlebars helper which returns true if the first parameter is greater or equal to the second. That first parameter is the value of the property we're interested in. Note the ... notation, as since we're inside the times helper, we have to go up a level to get back to the context where that information is. Finally, the @index tells me which iteration I am in the times loop. This is something I added to my times helper, so do note that you can pass any information you want in your custom helpers to be used in the template. This is how I render the numbers in the wounds section of the sheet. Back to the sheet, now it's all reverted back to normal since the value of marks of death is currently 0. So let's give ourselves the ability to change this value. What I want to happen is that when I left click on any of the skulls, it increases the value by 1 and decreases by 1 when I right click. What I can do in activateListeners is instead of adding 2 functions, one for each type of click, I can use the jQuery on function to bind multiple events to a single callback, in which we can then branch the behavior depending on the type. Note that I'm ensuring that we don't go lower than 0 or higher than 6. And there we go. Now I can update the marks of death value. Okay, only a few more things to go. We can change the wound points on an actor's token, but sometimes we might want to do this from the sheet. I could use the same method I used for the marks of death, but having to right-click 10 plus times to clear your wounds would be annoying. So what I'm going to do instead is making so that clicking on a number sets the wounds value to that number. And if it's already set to that value, I'll remove the wound at that point so that I can completely clear wounds. I'm going to do something similar on the right click to set impairment threshold, though I'll put it behind the context menu as it's not an action that people will do often. Finally, I need to be able to set any extra impairment the character might have. However, the character sheet has no dedicated space for it. So what I'm going to do is create an input field that will start hidden and only show it when I click on the wounds point text at the bottom left of the sheet. I'll create this in the same div as the wound points, give it a hidden class that just sets its display to none in CSS. Then I'll give this absolute placement so it displays over the wound points. I'll need to put a solid background on the input field too. Nothing special in JavaScript, just need to listen to the click event on our button, retrieve the impairment editor, and toggle the hidden CSS class. Doesn't look good, but I'll figure something out when we get to styling. And with this, our sheet is fully editable. To finish things off, we actually need to restrict some of the things we've done. You see, as it stands, all those listeners we've added will be activated for anyone who can open the sheet. And we don't want that, especially as some of these allow us to make edits to a sheet that might otherwise be uneditable. The activateListeners function is usually split into 3 sections. First, you have the listeners for everyone. I don't have any in my case. Then we have the listeners that are only available if the list is editable, as we said earlier. We can gate that by testing if the sheet is editable. Finally, we have events that we want to restrict to the owner of the actor, and you can test this with the slightly misleading this.actor.owner. Owner-only listeners are usually for rollable buttons, of which we have none yet. Though, before we get to that, I'd like to make this sheet prettier, which we'll look at next time. See you there!